line in 3D. So to understand straight line in 3D, its equation, you need to know two things. The first one is how to find position vector. Number two, concept of two parallel vectors. So if I start with first point, to find out position vector. To find out position vector from 2 points, let's have A and B, 2 points on a vector AB. Okay, so vector AB, the position vector, basically in terms of coordinates, because if you don't know the coordinates, then you just say AB. But if you have coordinates, I'm taking one example, 2, 3, 4, or 0, 1, 2, for example. Okay, so I have two coordinates A and B on a vector AB. So how to find out position vector of AB? It's very simple. Final minus initial. So final minus initial. So position vector of B minus position vector of A. So 0 minus 2, 1 minus 3, and 2 minus 4, which is minus 2, minus 2, minus 2. Okay, so this is a column way of writing a vector, or you may write like this: minus 2i plus minus 2j minus 2k. So this is the way how you get one vector from 2 points. The second point is concept of parallel vectors. You see there are two vectors, A and B. They are said to be parallel, okay, if they share something common. If they share something common, so if they are sharing something in common, both of them, for example, A is a k times B. I mean to say A can be half of B, the magnitude, but the direction will remain same, or A is double of B, something like that. So that's what we generalize. Two vectors are parallel if they are right, if they can be written is in this format: A equals to k times B. So k is a number. This number can be positive, can be negative, even a fraction. So don't worry about that. You just need to see the ratio of components. If it is same, it means two vectors are parallel. Okay, so after understanding these two things, you can start with a straight line. So here is line in 3D. So I have a line and I have a fixed point A and I have a general point R. Okay, you can see here A and R, X, Y, Z, and A1, A2, A3. Guys, you can recognize R is the general point, means R is representing any point on the line, but A is fixed point. So I will write here it's a fixed point, or maybe you can say this is your starting point from where you start the line. Okay, now to understand the concept of straight line or to get equation, you need to have two things. Number one, in which direction your line is going. Direction, I mean to say like slope. Okay, like slope in 2D. Similarly, we have direction in 3D, or especially in vectors. So we don't say slope in vectors, we say direction. So we have a vector, particular vector B, which is parallel to my line, which is going through A and R. So if these two vectors, because of course if I say AR is a vector, there is no problem to say that. So AR vector and B vector, they are parallel. AR vector and B vector are parallel. So AR can be written as any constant times B vector. Okay, I'm representing by arrow just to specify that these are vectors. Now guys, if you know how to get AR, because you already have 2 points. Okay, so X minus A1, Y minus A2, and Z minus A3. Okay, equals to T times the direction of a line is already given, because the line is already parallel to a vector B1, B2, and B3. Because these are the two conditions you need to have to give equation of any unique line. Okay, so from here I will rewrite it. So x equals to, see, all are negative. So if I move these points on other side, you will see like this, a1 plus t b1. Okay, if you want to continue to writing down in a column form, so you can continue like this, or you can also convert in other form. The other form is, we call it parametric form. So guys, this is the vector equation. So vector equation of a line is basically this same one where we got it, x y z a1 a2 a3 t times b1 b2 b3. Now there is another format of writing equation which is called parametric equation. So parametric equation is actually when you write all the coordinates separately, x, y and z, sorry, all points. So if you say, what is x from here? a1 plus t times b1. So that's what we are writing here. So a2 plus t b2, a3 plus t b3. So all these points, so you can say, so we are using to represent parametric equation. Okay, now of course in exam they may ask you write down in vector form or write down in parametric form. So if you know parametric, you can interconvert them. Now there is a question, find vector equation and corresponding parametric equation of a line through this and direction. See guys, direction is given, I mean slope is given, or in other words the first fixed point is also given. So you just need to plug these values here and here. So a1 a2 a3 is given by 1 minus 2 3 because it is a point, because it is passing through one particular point, and it is in the direction of 4i plus 5j minus 6k, because this is the direction which is actually the direction of my line. Because if this vector or my line, they are parallel, it means they have the same direction. So you need to switch x y z is fine equals to 1 minus 2 and 3 plus a constant, a scalar number. You don't need to put this any particular value. So here you put these points. So because of t times of this vector, my line becomes parallel to this vector and my line is passing through this particular point. So I have to satisfy this point, 1 minus 2 and 3. So this is actually vector equation of this line. And if you want to say the parametric equation, that's quite easy. If I write here, and so x equals to 1 plus 4t, okay, and y is minus 2 plus 5t, and z equals to 3 minus 6t. Okay, so that's what you call it, parametric equation, and this is vector equation. Let's move on. Now we have another case. Now we don't have direction, we have 2 points A and B. You already know in the first slide I explained you how to figure out position vector through 2 given points. That's the situation here, 2 minus 1 and 4 and minus 1 0 and 2. So as I explained before, vector AB is minus 1 minus 2, 0 minus of minus 1, so plus 1, and 2 minus 4. So you can say minus 3, 1 and minus 2. So this is your vector AB. Okay, now we need equation, we don't need only direction. So if you say my line is passing through A or B, any point, because of course my line is passing through A and B both. So I can consider, if you remember the previous equation, we had here A1, A2, A3 and B1, B2, B3. This is parallel vector and this is the particular point. Okay, so that's what we are going to use here. So vector AB we already got here, and we can use points, or maybe we can just write down like this, X, Y and Z. equals to any one point here, either A or B, because the line is passing through both. So let's say A plus a parameter T and the parallel vector. So the vector and the line, they are parallel to each other because they are superimposing. So I can say -3, 1 and -2. So this is the required vector equation, and if you convert them in separate points x, y and z, this becomes your parametric equation. Okay, here we have some problems based on these two topics. So I have to find out vector equation and parametric equation. A line parallel to this passes through this. I think it's quite easy. So I will just say x, y and z equals to, okay, the point is 1, 3 and -7, okay, plus t times the point, sorry, the vector which is parallel to this. So 2, 1 and 3.